It's embarrassing that while SpaceX successfully lifted its rocket to orbit, Blue Origin has still struggled with its suborbital launches. It's true, the debut launch of the latest model of Blue Origin's new Shepard suborbital vehicle, at first glance, occurred with flying colors. However, in reality, it hides serious problems that the company itself avoids talking about. This once again raises skepticism about a culture of cover-up within the company. Find out everything in today's episode. To start, let's use one word to describe Blue Origin. You can feel free to share your idea in the comment below. In my view, I will nickname them Blue Origin's Secret, simply because I'm a big fan of Victoria's Secret fashion show. Okay, I'm just kidding. Primarily caused by Jeff Bezos, Blue Origin's CEO prefers to hide many things about the operation of his company, including the New Glenn rocket's development, and even the data around the first flight of a new model of its new Shepard suborbital vehicle, called NS-27. On October 27th, NS-27 saw the first uncrewed test flight of the second new Shepard vehicle, designed to carry human passengers high off the Earth, but not into orbit. It occurred after 2 scrubbed attempts on the 7th and 13th, respectively. The launch is called by the company as nominal and on target despite 2 weird points. First, NS-27 appears to be less successful than its previous test flight, NS-26. Its first-stage rocket, called Booster 5, reached a peak altitude of 102.3 kilometers above sea level, while Blue Origin's new crew capsule, RSS Kármán line, flew to an apogee of 102.4 kilometers. On NS-26, the capsule went to 105.4 kilometers. Previous New Shepard flights, both crewed and uncrewed, have typically flown to altitudes of between 105 and 107 kilometers above sea level. It stems from the engine shutdown on NS-27 took place about 2 seconds earlier than the previous flight. NS-26 had a maximum ascent speed at engine shutdown of 3,602 kilometers per hour, while NS-27's maximum ascent speed was 3,473 kilometers per hour, according to data released by Blue Origin. A lower speed at engine shutdown would result in a lower apogee. So, what's wrong with the new model? Of course, we have no idea about it because the company didn't explain. They also didn't publicly release statistics about the flight, including peak altitude and speed as it normally does. It's safe to say that it would be normal to have an anomaly in the first flight of any vehicle, not to mention this is the testing of New Shepard's new model. Anyway, it is apparently close enough to the mark for Blue Origin. However, what puzzled us the most was BO's cover-up, which reflected that something was not quite right inside the company. That's the problem. It's been 24 years, and from outside of the company, all we see is big talk and little results. We have been waiting for the debut of BO's New Glenn rocket, which is advertised as a Falcon 9's competitor. New Glenn is a heavy-lift launch vehicle and is being used for placing crewed and uncrewed payloads into Earth orbit and beyond. Like SpaceX's Falcon 9, New Glenn is a 2-stage booster with a reusable first stage that, mission planners hope, will land vertically after stage separation. New Glenn has experienced a slow development and manufacturing process that has led to significant delays. Development of the New Glenn rocket started before 2013 and was formally announced in 2016, with an inaugural flight planned for 2020. However, that date has come and gone without any launch. Another light hope has come as the company announced a new launch date for the long-awaited vehicle, no earlier than November 2024. To add to the certainty, they also said that this launch will carry a prototype Blue Ring spacecraft and serve as its first certification launch for the Space Force's National Security Space Launch Program. News on the rocket's development has been updated more frequently, with the latest news indicating that the installation of 7 B-4 New Glenn engines has been completed. While we don't know if a November 2024 launch date is feasible, here's hoping they can make it happen. How about you? Do you believe that the inaugural New Glenn launch could happen in November as planned? Let me know in the comments. Like Elon Musk, Jeff Bezos also has a big dream of colonizing space. Build enormous space stations that would allow 1 trillion humans to live throughout the solar system. Though he said he won't see them built in his lifetime, Bezos founded Blue Origin for the purpose of making his vision come to life. Musk has his sights on Mars, saying he wants to establish a permanent, self-sustaining human colony of 1 million people on the red planet by 2050. SpaceX is helping him toward that goal. Nevertheless, as you can see, despite sharing the same vision with SpaceX, BO is opaque compared to Elon's company, which often gives the impression that there just isn't any progress to see. Alongside New Glenn, Bezos, in 2021, unveiled plans to build a private space station called Orbital Reef by 2030. The outpost will initially complement, but eventually take the baton from the International Space Station, which is expected to be retired in the 2028 to 2030 timeframe. Orbital Reef's envisioned customers include national governments, private industry, and space tourists. Brent Sherwood, Senior Vice President of Advanced Development Programs for Blue Origin, declared, "We will expand access, lower the cost, and provide all the services and amenities needed to normalize spaceflight," he added. A vibrant business ecosystem will grow in low Earth orbit, generating new discoveries, new products, new entertainment, and global awareness. That's an amazing plan, and fans of space exploration were very excited about a promising future that BO drew for them. Ironically, that excitement has gradually disappeared when updates about the project have gradually dried up over time. Even in 2023, BO and its partner, Sierra Space, navigated a potential end to the Orbital Reef partnership. In the latest update on NASA's website in March, Blue Origin's Orbital Reef recently completed testing milestones for its critical life support system. But on X, the latest information about the project still stops last December. Clearly, Blue's fans are more pessimistic than anyone else. In contrast, SpaceX enthusiast seems to be the happiest fan in the world, as almost every news about SpaceX's activities is provided on a daily basis. As of October 24th, SpaceX launched the 100th Falcon 9 liftoff of 2024, increasing the total launch of rockets from the Falcon 9 family to nearly 400 times. In this way, SpaceX has helped the United States lead the world in the number of orbital launches and total payloads into orbit. And those record-breaking rockets weren't the only recent major accomplishments by SpaceX. On October 13th, the SpaceX Starship rocket left the whole world in awe with the unprecedented performance. Under Starship's 5th test flight, its gigantic Super Heavy rocket booster, for the first time, returned to the launch site and was caught mid-air with a giant chopstick-like contraption called Mechazilla. Starship's success is a testament to human ingenuity and persistence onwards to Mars and beyond. Starship's maiden launch took off in April 2023. That launch aimed solely to get the 121-meter vehicle off the launch pad. And it did just that before exploding minutes into flight over the Gulf of Mexico. Based on data collected from the first flight, SpaceX entered the second attempt on November 18, 2023. The test marked a new milestone for Starship's development, as the rocket successfully lifted off. All 33 Raptor engines on the Super Heavy booster started up successfully, and for the first time, completed a full-duration burn during ascent. Starship separated from Super Heavy successfully as well, via a technique known as hot staging. However, the upper stage, known as Starship, exploded about 8 minutes after launch, the same fate that met the vehicle's huge first stage, called Super Heavy, 4.5 minutes earlier. SpaceX launched the third test flight of its Starship rocket on March 14th and reached space as the company pushed development of the mammoth vehicle past new milestones. The rocket flew further than previous tests, with the flight lasting about an hour before Starship broke up above the Indian Ocean. The company noted that the vehicle did not splash down in the water, which was the intended ending of the flight. The flight represents a significant step towards SpaceX, completing prototype testing and beginning operational Starship launches. For Starship Flight 6, SpaceX quickly rolled out a Super Heavy rocket for the upcoming test flight, manifesting that the test may be soon. The company performed a static fire on September 18th at its Starbase site in South Texas, briefly igniting the 6 Raptor engines of Ship 31, the upper stage of the vehicle that will conduct the 6th Starship test flight. Following Ship 31, its booster, B-13, also took part in its owned static fire test on October 24th. Boeing, once the American greatest aerospace company, now is a titan in a crisis largely of its own making. When mentioning Boeing's current trouble, one compares it to the Hydra of Greek mythology. For every problem that's come to a head, then been severed, more problems sprout up. And the company's Starliner program is the most obvious example of that, with the spacecraft having been plagued by problems for a decade. To completely solve this mess, Boeing has decided to sell its iconic space business, and this time, the potential buyer is a very familiar name, Jeff Bezos' Blue Origin.
What?
As usual, taking the helm of any of the world's largest manufacturers is an ambitious man's dream, because it provides reputation, power, and money. But for Kelly Ortberg, Boeing's newest chief executive, such things seem nothing compared to what he's facing. When taking over Titan Aerospace, which is at rock bottom, Ortberg, a 64-year-old Midwesterner, says his mission is pretty straightforward: turn this big ship in the right direction and restore Boeing to the leadership position that we all know and want. However, things are certainly never going to be easy. On the contrary, it is going downhill even further. In mid-September, more than 30,000 Boeing workers began striking for better wages, pensions, and health care. This strike has been 6 weeks, resulting in serious financial damages for the company, costing Boeing an estimated $50 million a day, pushing back the day it can resume production of most aircraft, and further stressing its supply chain, contributing to the second worst quarterly result in its history, with a $6 billion loss between July and September. The dire situation shows no signs of stopping, as the two sides have yet to reach any agreement. Boeing's current collapse is not surprising, as it is the result of a domino effect. For the better part of 5 years, all we saw at the company was chaos. Under Dennis Muilenburg's era, 346 people were killed in 2 crashes involving Boeing 737 MAX planes within the span of almost 5 months, first off the coast of Indonesia in October 2018, and then in Ethiopia in March 2019. These serious incidents led to the worldwide grounding of the Boeing 737 MAX passenger airliner between March 2019 and December 2020, and again in 2024. The firm continued to reel from the COVID-19 pandemic, which depressed demand for new airplanes, causing a record loss in 2020 of up to $12 billion. To make matters more complicated, investigations regarding the 737 MAX accidents occurred, which then forced Boeing to agree in July to plead guilty to a criminal charge of fraud for misleading regulators about the plane's design. Fast forward to January 2024, the fleet of Boeing 737 MAX again made plague after an Alaska Airlines flight was forced to make an emergency landing when a door plug fell off the fuselage mid-air. One more time, according to the FAA's order, 737 MAX 9 planes that operate in U.S. territory later were grounded, affecting about 171 of the airplanes, out of 218 worldwide. Not only is Boeing struggling in commercial aircraft, it is also struggling with heavy losses in the aerospace sector. The company's Starliner space taxi program hasn't seen a single smooth phase from the day of the contract signed with NASA. It's been plagued with controversies, technical problems, and delays that make the vehicle not to be certified yet after a decade. Notably, its biggest mishap came earlier this year when a crewed test flight took 2 astronauts to the space station, but left them stuck there due to glitches with the capsule. Boeing's financial health is even more fragile, as total losses on Starliner are towards $1.85 billion, even though Starliner is a relatively small portion of Boeing's overall business, but it's a high-profile and unprofitable one. When the situation is beyond saving, the best solution is to sell it. Yes, according to sources, Boeing may put its iconic space business up for sale and had talks with Jeff Bezos' Blue Origin. In addition, the sale includes operations related to the International Space Station, but would not include NASA's massive Space Launch System rocket. This allows CEO Kelly Ortberg to focus resources on commercial aircraft and defense divisions, as he puts it, doing less and doing it better. Such considerations occurred even before Kelly Ortberg took over as CEO in August. Before he came on board, Boeing held discussions with Jeff Bezos' Blue Origin space company about taking over some NASA programs. It's safe to say that Boeing's despair about the Starliner program partly stems from NASA's decision in August to bring the astronauts back to Earth on a SpaceX mission in February 2025, pushing the astronauts' total time in space to 8 months, if all goes according to plan. Afterward, Calypso had to sadly return home from space empty on September 6th. While former Boeing CEO Dave Calhoun blames for fixed-price contract as the main reason for the matter. In fact, who killed Boeing is the company itself, not someone else. In 1997, Boeing made a history merger with McDonnell Douglas, valued at approximately $14 billion, which allowed Boeing to consolidate its position in the aerospace industry. While the firm had a great aerospace tradition in building airliners, starting with the iconic DC-3, McDonnell Douglas found it increasingly difficult to compete with first Boeing and then Airbus. By the time the Soviet Union collapsed, the company's military business had fallen on hard times, and it had to be very sensitive to costs. Lacking the resources to embark on new product development, merging with Boeing was McDonnell Douglas's way to exit the industry. However, while the firm's name was retired, the McDonnell Douglas management team did not leave quietly. In fact, the tougher, leaner managers of the weaker company elbowed out the more gentlemanly leaders of the bigger company. The result was that Boeing's idealistic engineers ended up being run by McDonnell Douglas hard-bitten veterans. These were accountants, financial controllers, and other managers obsessed with cost savings and used to running things on a shoestring budget. They were also very sensitive to shareholder wealth. One money-hungry CEO described those who cared too much about safety and quality rather than the company's stock price as, quote, phenomenally talented assholes. To appease Wall Street and boost its stock price, Boeing has engaged in substantial stock buybacks, spending billions to enhance shareholder value. This approach has been criticized as it diverts funds that could otherwise be invested in safety improvements and technological innovation. It doled out hundreds of millions of dollars on campaign contributions and lobbying to lower safety standards, rake in massive government contracts, and boost its bottom line. In 2018 alone, the company spent over $15 million on lobbying efforts, making it one of the top players in Washington's lobbying landscape. This spending is aimed at influencing legislation and regulations that affect the aerospace industry, often focusing on lowering safety standards and securing lucrative government contracts. To cut costs, the new management approach encouraged extensive outsourcing and a modular design strategy, where a significant portion of design and manufacturing was delegated to external partners. This strategy aimed to reduce costs and development time, but often resulted in coordination issues and quality control problems, as seen in the troubled development of Boeing's Starliner spacecraft. Take the case of its propulsion system, for example, which has failed several times in both the 2022 uncrewed test flight and the first crewed test flight. While SpaceX developed its Draco and Super Draco thrusters internally for Dragon, Boeing took a more traditional path, turning to industry leader Aerojet Rocketdyne for Starliner's various thrusters. In turn, Rocketdyne had its own myriad subcontractors. One of the big differences between new space companies like SpaceX and traditional space companies is vertical integration. If it works well, developing and building one's own technology is faster, cheaper, and much more efficient. Everyone is also on the same team and pulling in the same direction. By contrast, partnerships between two large aerospace corporations are often cumbersome. The need to coordinate across multiple teams, obtain approvals, and navigate different corporate cultures and processes can make even simple tasks like designing a widget an arduous undertaking. Even if a problem does occur, it becomes much more complicated to resolve because this involves a dozen different people in different departments at different companies have touched the part. As a result, it adds time and cost, and no one feels ownership of the process. At a new space company, the process can be much simpler. An engineer designs a part and writes a purchase order for the shop to build it. As an engineer, you're supposed to solve hard problems, but the structural inefficiency was a huge deal, said one person familiar with this process at Rocketdyne and Boeing. Additionally, can't help but mention a poor working relationship between Rocketdyne and Boeing. That relationship was severely strained in June 2018 when the Starliner spacecraft experienced an anomaly during a hot fire test of its launch abort system. Boeing and Rocketdyne more or less hated one another, according to sources. Everyone was in super defensive mode even before this happened. It had been classified as a risk, but the two sides weren't talking openly and honestly about it. NASA's Artemis program, as a reincarnation of the now-canceled Constellation program, is increasingly mired in trouble even though it has just started. Prior to the unpiloted Artemis 1 test flight in late 2022, NASA's SLS rocket, Artemis's main launch vehicle, was criticized for its cost overruns and delays. Additionally, during the re-entry of the Orion spacecraft under Artemis 1, its heat shield was detected to be cracked and chipped away. What caused it became a burning question. The persistent investigation into the heat shield issue forced NASA in January to announce a delay in the launch of Artemis 2 from late 2024 until September 2025. Finally, hard work pays off. NASA currently knows what caused the erosion of the Orion spacecraft's heat shield following its historic trip to the moon in 2022. However, what confuses us the most is NASA's weird silence. We have conclusive determination of what the root cause is of the issue. Lori Glaze, Acting Deputy Associate Administrator at NASA's Exploration Systems Development Mission Directorate, said, "But I'm not going to share right now. When it comes out, it will all come out together. After the root cause analysis is done, the space agency will be running additional tests to mitigate the crew capsule's erosion during atmospheric re-entry, which will be completed by the end of November. This clearly shows that they know exactly what is wrong and how to fix it going forward." Nevertheless, there is a problem. The heat shield for Orion that's going to be used for Artemis 2 has already been installed at the bottom of the crew capsule. Therefore, replacing any of its components would require undoing the spacecraft. This would certainly delay the Artemis 2 mission by a year or more. At this point, there are two options for NASA managers. Either decide it is safe enough to fly the Orion heat shield as is on Artemis 2, or it is too risky with people on board. We know what needs to be done for future missions, but the Artemis 2 heat shield is already built. So how do we assure astronaut safety with Artemis 2? Glaze said. NASA astronaut Reed Wiseman, Artemis 2 mission commander, shared a similar sentiment. "This crew, we're not going to launch until we know we're ready, until our team knows that the vehicle is ready, and we will keep the pressure on." In such a sensitive context, it is not difficult to understand if NASA keeps the Orion heat shield problem secret. It might be because it could be really bad. You know, NASA is often well known for being less transparent about issues. A typical example is the case of Boeing's Starliner's first crew test, when they initially hid a lot of information, and only provided information in a drip manner under the public's pressure. This is pretty similar to what happened in the Orion's heat shield investigation. The agency first revealed the unexpected performance of the Orion heat shield in March 2023. 4 months after the end of the Artemis 1 mission, and we have to wait nearly a year and a half after the mission's return to Earth to see a report from NASA's Inspector General Watchdog that included the first publicly available images of the Orion heat shield's condition after splashdown. Another report released by the Government Accountability Office, GAO, in June said a preliminary analysis of the heat shield problem suggested to engineers that the permeability of the material was lower than their models had indicated. On the other hand, some argue that NASA should be sure before making anything public to avoid a major media crisis. Talking about this, someone who works in aerospace and thermal analysis gives his own opinion. "I've made mistakes over the years of giving people predictions too early, and it always bites you in the ass. I tend to not report things these days unless I feel fully confident in what I'm reporting, because people will 100% run with whatever you give them." So, how about you? Is it reasonable for NASA to remain silent about the root cause of the Orion heat shield during this time? Feel free to share your thoughts in the comments section below. So, is there any alternative option in this case? Frankly, a few years ago, facing the long-term delay and the exorbitantly high costs of both Orion's crewed spacecraft and the SLS rocket, some aerospace engineers suggested NASA should consider SpaceX's Dragon as the low-cost alternative. In theory, Crew Dragon virtually fits this mission. It has a dry mass of fewer than 10 tons and 50% more internal space than the Apollo capsule that carried 3 astronauts to the moon. SpaceX's Falcon Heavy is certainly capable of launching a Dragon capsule with a crew and a hell of a lot of cargo at the same time. There, the vehicle would dock with a lunar lander that would carry the crew to the surface, while the Crew Dragon capsule remains in low lunar orbit. After sciencing on the moon, the astronauts would use the lander to return to the Crew Dragon, fire the return stage, and come home to Earth. This idea helps to dispel the concern of NASA Administrator Bridenstine, who was dismissive when asked about using Dragons instead of Orion for the Artemis program. I think it's important to note that Crew Dragon was specifically designed for low Earth orbit, and in order to send it to the moon would require a ton of modifications, he said. I'm not saying you couldn't modify it, but if you modified it, it would look a lot like Orion. Additionally, SpaceX previously planned to build a big-size version of Dragon, called Dragon XL. That spacecraft would weigh around 15 to 16 tons at liftoff and likely require a fully or partially expendable Falcon Heavy launch for each mission to the moon. Although it initially was required to transport cargo only under NASA's 2021 Gateway Logistics Services contract, SpaceX can come up with the idea to transfer it to the crewed version. It seems to be a fairly balanced and reasonable choice for both SpaceX and NASA, leveraging existing investments and experience with SpaceX and Dragon, and erecting no major technical hurdles. Nevertheless, there are a few obstacles here. Honestly, the Pika X heat shield used on Dragon cannot withstand 2,760 Celsius during re-entry from the moon, hotter than a spacecraft sees when it re-enters the atmosphere from low Earth orbit. Pika is lighter, more brittle, and is installed in tile form with gaps. The A-coat heat shield on Orion can be installed with no gaps, but is harder to manufacture. 2 different materials for 2 different mission profiles. Returning from LEO versus returning from the moon. NASA is afraid to completely change the type of heat shield on the spacecraft because it would probably harm Artemis's timeline. Not to mention, Falcon Heavy is not a human-rated rocket yet. Handling this matter also requires working on an unexpected level of complexity and time. As for using the Falcon Heavy as the launch vehicle for the Orion capsule, there are several issues with this scenario. First and foremost is the rather porky mass of the Orion and the relatively low high-altitude performance of the Falcon upper stage. The Orion capsule weighs in at over 33 tons at launch, complete with the service module. But the Falcon Heavy is only capable of delivering something in the order of 23 tons to lunar orbit, even in fully expendable mode. Another issue is the size of the Orion capsule itself, which at a diameter of over 5 meters, is already at the limit of such a fine rocket, red, skinny, and long. The Falcon's basic structure was never intended to launch something as large as the Orion, and in order to make it work, you would need to basically redesign the bulk of the vehicle, which requires lots of time. Currently, SpaceX wants to focus more on Starship rather than Dragon or Falcon. As the world's most powerful launch vehicle ever developed, Starship is capable of carrying up to 150 tons of fully reusable payload and 250 tons of expendable payload to low Earth orbit. Better than the Falcon rocket, Starship is fully reusable, which significantly reduces the cost per launch. While SpaceX's Falcon rocket line has a base price of $70 to $150 million, Starship stands out much more with a price tag as low as $2 million to $3 million. In the long term, SpaceX's new generation rocket is certainly a perfect replacement for the company's current rockets, including Dragon and Falcon. October must be the best month for SpaceX. They have made the hairs on our necks stand up with the most incredible engineering feat ever seen in global space exploration. For the first time, a 23-story skyscraper was caught on 2 tiny little hooks by metal chopsticks. It's truly a great victory, paying off for the company's efforts to build a reusable vehicle for use on the moon and Mars. Of course, looking at things from a broader perspective, this victory is not only about Mechazilla successfully catching the Super Heavy rocket. The entire launch and return were available to be seen throughout the world via a reliable high-speed internet owned by the company, Starlink. This satellite constellation system offers unlimited high-speed data through an array of small satellites that deliver up to 150 megabits per second of internet speed. So far, there are 6,426 Starlink satellites in orbit, of which 6,371 are working. It connects more than 4 million people with high-speed internet across more than 100 countries, territories, and many other markets. Through the fifth flight of Starship, Starlink once again proves its top quality by transmitting the entire perspective of the flight to viewers around the world, contributing to a big media effect. This not only helps the company to attract more fans, but also enhances its position and reputation for the government. It comes in handy in a context where SpaceX is facing political conflicts against attackers who are mostly Democrats. For example, we know that on October 15th, SpaceX filed a lawsuit against the California Coastal Commission after the commission voted on October 10th to block the rocket company from conducting further launches on the state's central coast. The key point here is the reaction of the U.S. Space Force, SpaceX's main customer in this location. Prior to Starship's launch, they were in favor of California officials by agreeing to all commission's demands. But the amazing part is that 5 days after the fifth test flight, they seemed to change their mind by awarding SpaceX a huge contract worth $733.5 million for national security space missions. These launches are to give a heads up when bad guys attack us by launching missiles. Worth noting that all of these national security launches would take place from Vandenberg, where the California Coastal Commission rejected SpaceX's rocket launch expansion. With such support, we can absolutely believe that SpaceX's odds of winning this lawsuit are very high. Who knows? The importance of national security launches is off the table. So between the national missions and political battle, which one should be prioritized? Simultaneously, SpaceX has also another guarantee for its winning, which is the support of California Governor Gavin Newsom, despite the conflict in the past between this Democrat man and SpaceX CEO Elon Musk. So far, it's unclear what actually happened behind the scenes. We just know that no matter who will be the next U.S. president, the Pentagon really needs SpaceX. The company's Starship project, although has not come online, catches the military's eyes with many promising functions. As the largest and most powerful rocket ever built, Starship can carry up to 150 tons of payload to LEO, allowing it to transport sizable military equipment, such as tanks and helicopters, and humanitarian supplies during disaster relief operations. It's equivalent to the capacity of the largest military plane in the world, Antonov An-124 Ruslan, developed by the Ukrainian company Antonov in the 1980s. However, with approximately 800 kilometers per hour of speed, Antonov is still much slower than Starship with a speed of 28,000 kilometers per hour. Such superfast speed helps the rocket to reach any destination on Earth in under an hour, with most international flights completed in a mind-boggling 30 minutes, which is a vision that SpaceX confidently foresees. Confidently realizing that potential, in February, the Pentagon spoke to the company about procuring its own fleet of Starship rockets for sensitive missions. At present, the U.S. government relies on non-military contractors to launch payloads for various operations, including satellite launches, and does not have its own space launch vehicles, at least any that are disclosed, which it could deploy in a potential contingency scenario. SpaceX is already working with the Air Force and Space Force on the Rocket Cargo program, which seeks to rapidly deliver cargo and possible personnel anywhere on Earth that can support a landing. Purchasing the whole Starship will be very useful in some cases where there needs to be a government-owned, government-operated launch vehicle, and that transfer can happen on the fly. With the stunning success of Starship's October 13th test flight, the Space Force has more evidence to believe what SpaceX promises them. Of course, to make that happen, what does the Starship development phase need? First and foremost, it's money, a lot of money, up to multi-billion dollars. And one of the best ways is through the lucrative military contracts launched by SpaceX's Falcon Heavy. You know, launch prices for NASA and military payloads run higher than SpaceX's base commercial price. Government satellites often require special handling, resulting in extra fees in some terms like engineering insight, unique cleanliness specifications, and in some cases schedule priority over other commercial missions. The area where Falcon Heavy really shines is heavy satellites meant for distant orbits, and mostly includes military launches. In early 2023, Falcon Heavy was warmed up with the USSF-67 mission in mid-January. Here, a new center core in an expendable configuration was applied, while the two reused side boosters landed at Cape Canaveral Space Force Station. Next in May, they moved on to the Viasat-3 launch. The next three included Jupiter 3, Psyche, and Boeing's X-37B spaceplane. In addition to the military, the arrival of the rocket helped reverse the upward trend in NASA launch prices. In 2020, NASA awarded a $117 million launch contract to SpaceX for a Falcon Heavy launch of Psyche. 1 year later, we witnessed a $178 million contract being awarded by NASA for Falcon Heavy to launch Europa Clipper. Later the same year, there was a trade valued at $152 million between the space agency and SpaceX to launch a large new NOAA weather satellite. SpaceX beats Yuli to win $730 million to launch at least 9 national security missions, once again demonstrating the Falcon Heavy's immense capabilities over its competitors. The Falcon Heavy is one of the most powerful operational rockets, capable of lifting large payloads into various orbits. Falcon Heavy has the second highest payload capacity of any currently operational launch vehicle behind NASA's Space Launch System, and the fourth highest capacity of any rocket to reach orbit, trailing behind the SLS, Energia, and the Saturn V. This capability is crucial for military missions that often require deploying multiple satellites or large spacecraft simultaneously. For example, the USSF-67 mission successfully launched a military communications satellite along with 5 smaller payloads, demonstrating its capacity to handle complex missions. With a base launch cost of just $90 million, Falcon Heavy can launch that cargo for just a fraction of the price United Launch Alliance charges for the service. Atlas V starts at $109 million, whereas the company's other type of rocket, the Delta IV Heavy, costs upwards of $350 million a launch, limiting its use to government customers. Even ULA's low-cost Vulcan Centaur has a price tag of around $100 or $200 million. The low cost stems from the reusability of first-stage boosters, which can return to Earth and be refurbished for future launches. This reusability not only reduces costs, but also increases the frequency of available launches, allowing for rapid deployment of military assets as needed. Last but not least, the Falcon Heavy incorporates advanced technology that can support various military applications, including experimental missions like those conducted by the X-37B spaceplane. These missions often involve testing new technologies and conducting research that contributes to national defense capabilities. In the satellite field, SpaceX also demonstrates its big contribution to security missions by providing and funding Starlink services to Ukraine largely on its own. It's where Starlink demonstrated it could operate in a combat zone and proved to be more resilient than the U.S. military would have expected from a commercial system. However, for Elon Musk, Starlink needs to be a civilian network, not a participant in combat. That's where a military version of its Starlink satellites called Starship comes in. Starship is also capitalizing on SpaceX's participation in the U.S. Space Force's Space Development Agency's missile tracking and missile detection constellation, where it partnered with Leidos to develop 4 classified infrared sensor satellites scheduled to launch before the end of the year. When SpaceX was founded in 2002 by Elon Musk, as far as I know, there were only about 50 spaceflights conducted each year worldwide, primarily dominated by government agencies and a few established aerospace companies. However, everything has changed just 2 decades later. Now, the legacy companies stepped back for the wave of commercial spaceflight, pioneered by a young private company, SpaceX. The total number of launches conducted by the company alone exceeds that of all other nations, plus all other U.S. launch services provided. This not only helps SpaceX quickly climb to a monopoly position, but also puts the United States in the world leadership position in this industry. In last October, SpaceX continued to push the boundary, marking its 105th rocket launch of 2024 overall. A Falcon 9 launched a batch of next-gen spy satellites for the U.S. National Reconnaissance Office, NRO, from California's Vandenberg Space Force Base. Bear in mind that over a week ago, or on the 15th, the company already set a record with its 100th successful flight. With this rocket launch, SpaceX excellently surpassed its own record of 98 launches in 2023, and is a prime example of how the company is redefining low-cost access to space, thanks in part to its reusable rockets. And those record-breaking rockets weren't the only recent major accomplishments by SpaceX. On October 14th, their heavy-lift launch vehicle, the Falcon Heavy, sent the Europa Clipper orbiter, the largest interplanetary probe ever built, on its way to Jupiter and its icy moon. It is one of NASA's most expensive scientific missions, with up to $5 billion, and SpaceX's Heavy rocket excellently beat NASA's SLS rocket to win this chance to conduct this mission. On October 13th, the SpaceX Starship rocket left the whole world in awe with the unprecedented performance. Under Starship's fifth test flight, its gigantic Super Heavy rocket booster, for the first time, returned to the launch site and was caught mid-air with a giant chopstick-like contraption called Mechazilla. Starship's success is a testament to human ingenuity and persistence onwards to Mars and beyond. On October 9th, a Falcon 9 proudly launched the European Space Agency's Hera spacecraft, which is on its way to check the damage done to an asteroid that was hit and smashed apart by NASA's DART mission. The mission was an attempt to deflect the asteroid in September of 2022, which incidentally also launched on a SpaceX Falcon 9. An interesting thing is that SpaceX completed all of those 5 milestone flights in less than a week, which both NASA and its other private competitors are not capable of doing. So what has brought SpaceX to the success it has today? First and foremost, they, from the very beginning, drew a clear path for themselves, chasing the reusable rocket idea. As the holy grail of rocketry, the reusability allows the vehicle to get access to the greatest feature: low cost per launch. The reason that space travel is so expensive is that we throw this expensive aerospace-grade rocketry away after each and every use, and so the holy grail of rocketry to make it less expensive. SpaceX believed that once they mastered this technology, they would make a breaking step in rocketry, and from there, own the future. Now the dream comes true. Honestly, the idea of reusable rockets is not new. In 1972, when Apollo 17 carried the last batch of astronauts to the lunar surface, NASA was already beginning the design and developing their next generation of crew-carrying craft. Nearly a decade later, the Space Shuttle was born. Shuttle was pretty darn reusable, but failed to achieve NASA's promised cost and utility goals, as well as design, cost, management, and safety issues. SpaceX is so smart to follow the process and learn from its mistakes to perfect its projects. This led us to SpaceX's second secret: standing on the shoulders of a giant. A prime example is how they applied it to the development of Starship. So, how can SpaceX ensure Starship won't fail like the Space Shuttle? To answer the question, we should delve into the real reasons why NASA's project failed first. NASA's mistakes could embrace the wrong estimation, inefficient technology, and its evolving attitude toward safety. NASA estimates that over the planned 14-year lifespan of the shuttle, the entire program will require a budget of approximately $45 billion, with each flight projected to cost around $54 million. But in fact, by the time the program concluded in 2011, NASA had expended a total of $196 billion, far exceeding the initial projections. The agency later tried to cut the cost, and the cost per launch was ultimately brought down to around $450 million, albeit not to the extent initially envisioned. The out-of-control expense was largely attributed to the extensive refurbishment necessary after each flight, resulting in the actual turnaround time averaging around 3 months. This is far exceeding the initial expectations of 2 weeks. The most time-consuming aspect of the refurbishment process was the meticulous inspection of the heat shield, requiring over 6 months of refurbishment by a large team. As Elon commented, "So was not reusable by any reasonable definition of the word." Due to the complex shape, the Space Shuttle requires an intricate arrangement of approximately 35,000 individual heat tiles, each requiring individual examination and assessment between flights. This painstaking procedure added significant time and effort to the post-flight operations. In contrast, most of Starship's heat shields are made uniformly, making the replacement and refurbishment much easier. Additionally, the reliability of the heat shield must be a top priority, meaning it must be able to protect the entire vehicle during descent, as well as remain intact after each flight. This is currently the biggest problem for the company because, in the previous test flights, some starbrick tiles still fell off. To handle this issue, SpaceX determined to redesign this system and tested it in Flight 5. They added the ablative layers beneath the primary tiles as an insurance policy. These secondary tiles are made from silicone and felt, meaning they self-cool by slowly disintegrating to expel heat. They also created the new tiles are about twice as strong. Fortunately, the new design worked well, and of course the flow of evolution will not stop here. Elon Musk said, "This will take a few kicks at the can to solve and requires building an entirely new supply chain for low-cost, high-volume, and yet high-reliability heat shield tiles. But it can be done." That means we'll see more heat shield testing on future Starship test flights, demonstrating SpaceX's strong commitment to safety, in stark contrast to NASA during the Space Shuttle era. There is a bitter pill that 2 fatal disasters during the Space Shuttle program were not primarily due to the vehicle itself, but instead viewed as victims of go fever, a sense of urgency that pushed NASA managers to neglect safety concerns. During the 1980s, to meet the ambitious launch schedule, which imposed significant pressure on NASA's upper-level management, potential safety hazards were often overlooked or downplayed. As SpaceX focuses on the Starship's development, it also tries to ramp up its progress, but avoids treading a similar path of cutting corners to meet self-imposed deadlines. They have applied the iterative approach, testing the vehicle through many test flights and learning from each test to improve the rocket. All of this was aimed at perfection, prior to allowing Starship to carry cargo and humans. Finally, we cannot fail to mention Elon Musk's spirit of not being afraid of failure. Between 2006 and 2008, his first 3 rocket launch attempts all failed, putting SpaceX on the edge of bankruptcy. The 4th launch succeeded, but only after Musk scraped together just enough money to finance it. So many of Musk's friends advised him not to do SpaceX. Luke Nosek, who helped build PayPal, one of Musk's former ventures, said. In an article for Forbes in 2011, aerospace and defense writer Lauren Thompson voiced concerns about NASA becoming overly dependent on the still young SpaceX, and also wrote that Musk's enthusiasm is infectious and inspiring. But SpaceX's performance to date doesn't measure up to the rhetoric. There was also doubt within NASA. Former NASA astronaut turned SpaceX engineer Garrett Reisman told CNN in 2020 that there was a perception of SpaceX along the lines of, "They're cowboys, they're dangerous, they're going to kill somebody." Musk had made a name for himself by voicing lofty ambitions for the company. He espoused self-landing, reusable, cheap rockets, and a wider goal of enabling humanity to become a multi-planetary species by colonizing Mars. Now let's look at them. SpaceX is truly the pioneer in commercial spaceflight, being a reliable partner with large national agencies like NASA and the Pentagon. Without a doubt, SpaceX's growth journey is definitely an inspiring story for any of us, anyone pursuing the dream of a better life. So how about you? Are you inspired by what SpaceX has achieved? Please share your thoughts in the comments section below. Half a month after Starship 5's flight, SpaceX is nearly ready for Flight 6, scheduled for November. At the time I made this report, B-13 was at the production site for flight readiness modifications, including one last check and installing the hot staging ring. Afterward, the booster along with the ship will go back to the launch site for final testing, and finally, launch. This quick turnaround time between flights could stem from not many upgrades on hardware, because SpaceX managed to catch the rocket intact on their first try without destroying it or the catching tower. Ship 30 also performed admirably throughout most of its journey in Flight 5 thanks to improvements in the heat shield system. However, there are still some challenges to overcome. Toward the end of the flight, the flap joint experienced burns, though less severe than in previous tests. This indicates that while design upgrades have already proven beneficial, further refinements are still needed. Despite this, Ship 30 completed its flip and burn maneuver and successfully landed in the Indian Ocean on target, which was caught by buoys that SpaceX had out at the projected landing zone. After the engine shutdown, Ship 30 tipped over and exploded after a transfer tube most likely snapped and mixed liquid oxygen and liquid methane. For the next Starship flight, SpaceX and Elon Musk have confirmed that the main players will be Ship 31 and Booster 13. Currently, Ship 31 is undergoing its transformation with its heat shield. Those heat shields are being removed by teams, and a new layer of insulation is being installed underneath. Once the work is finished, we will fully understand these changes. But many upgrades will likely build on what SpaceX did with Ship 30. However, because Ship 31 is still a V1 prototype of Starship, SpaceX's upgrades will be limited to what is possible at this stage. Therefore, with Starship's second generation, V2, the upgrades will be significantly expanded, including improvements to the forward flaps. Unlike what they used to be, the new front flaps on Starship 5.2 are more streamlined and angled, no longer having a bottom edge parallel to the ground when deployed. This new shape likely improves aerodynamics during re-entry and controlled descent. Elon Musk had been teasing these changes as far back as 2021, when he mentioned, "Forward flaps will change a lot in upcoming versions of Starship, smaller and more leeward. The flaps will be significantly smaller, reducing the aerodynamic load affecting navigation and the critical flip maneuver during landing. This design minimizes the risk of damage during flight and simplifies the manufacturing process, thereby increasing operational flexibility." Another change in V2's flaps is the thickness, which is reportedly about half as thick as the current generation. Once these flaps are thinner, the mass will substantially decrease, allowing for more load-carrying capacity. However, despite those discussions, the new flap design wasn't applied to the later V1 models. After the issues encountered with the flaps in Flight 4, this design revision resurfaced. Musk elaborated, stating that a newer version of Starship would shift the forward flaps leeward, improving reliability, ease of manufacturing, and payload capacity to orbit. After the Flight 5, Elon Musk proudly shared that, "I'm so glad we finally fixed the forward flap design. The old one was killing me, too large and heavy and positioned at 180 degrees, requiring large static aero and not fully stowed, so that pushes the nose backward during the high heating hypersonic phase of flight, which is the opposite of what you want." Making the flaps much lighter fits perfectly with Elon Musk's goals for the second generation of Starship. In his own words, Starship 5.2 aims to enhance propellant capacity, decrease dry mass, and bolster overall reliability. Initial assessments suggested that this updated vehicle would feature Raptor version 3 propulsion, along with the addition of 3 more Raptor vacuum engines, and be elongated by 5 to 10 meters, reaching a total height of 132 meters. This expansion would provide additional space for holding more propellant, further optimizing its capabilities. Let's go ahead and compare Elon Musk's latest update with our previous speculation. During the event on April 4th, Elon Musk revealed that Starship 5.2 will have a height of 124.4 meters, which is slightly taller than V1 by 3.1 meters, or less than what was previously speculated. However, despite the smaller increase in height, the stretch is more prominently reflected in the ship. An additional 1.8 meters allows for an expanded propellant area capable of holding an extra 300 tons. On the other hand, Booster will experience a slight increase of 1.3 meters, adding 350 tons of propellant. This difference in propellant capacity aligns with the expectation that Super Heavy, as the initial liftoff stage, would require more propellant. In the updated design, the upper stage of the vehicle retains 6 Raptor engines instead of 9. However, these Raptors will be significantly more powerful compared to those on Ship 5.1. The booster's lift will reach 8,240 tons of force. This thrust output is equivalent to 33 Raptors 5.3. each generating roughly 250 tons of force, whereas the ship's initial thrust is 1,600 tons. Raptor 3 promises to deliver more thrust, higher specific impulse, and various other improvements. What distinguishes Raptor 5.3 from its predecessors is the elimination of the heat shield, resulting in reduced dry mass. This reduction is offset by increased propellant and overall size of the rocket, while still maintaining a targeted payload capacity of over 100 tons to low Earth orbit. Additionally, the robustness and reliability of Raptor 5.3 play a crucial role in enhancing the rocket's overall reliability. After V2, SpaceX went further with the third version of Starship. Unlike the previous versions, Starship 5.3 is truly the culmination of thousands of design improvements. The most notable feature is its size, 150 meters tall, surpassing even the current launch tower in Boca Chica. The ship itself has also undergone significant dimensional enhancements, with a height of 69.8 meters, similar to the total height of the Falcon 9, while the booster stands at 80.2 meters. In perspective, Starship 5.3 is 28% larger than V1 and 20% more substantial than V2, exceeding Elon's initial expectations. He, in February, suggested that Starship version 3 would be at least 10 to 15 meters longer than its predecessor. However, the actual length difference between V3 and V1 is even more impressive, reaching up to 28 meters. This significant increase in length underscores the remarkable progress and ambition of SpaceX's Starship program. Along with the impressive height, Starship version 3's upper stage stands out by its superpower. As powered by 9 Raptor V4 engines, including 3 sea-level engines and 6 vacuum engines, the spacecraft can achieve an initial thrust of 2,700 tons, representing a substantial increase in power and capability. Perhaps even more astounding is the boost in thrust for the booster stage, which is poised to reach a new record of 10,000 tons of force. This extraordinary feat is made possible by a total of 33 Raptor 4 engines, each boasting an impressive thrust of 303 tons. Reducing the weight of components like the heat shield and adjusting the size of features such as the grid fins and flaps could indeed play a crucial role in managing the overall mass of the rocket. By optimizing these elements, SpaceX can achieve a balance between maintaining structural integrity and minimizing weight, ultimately enhancing the efficiency and performance of the Starship. Thanks to decreasing the size of both grid fins and flaps, SpaceX could potentially decrease drag and improve the rocket's overall flight characteristics, contributing to enhanced maneuverability and fuel efficiency. Additionally, advancements in materials and engineering techniques may allow SpaceX to achieve greater strength and durability with lighter components, further contributing to weight reduction without compromising functionality or safety. The decision to adopt a Soyuz-style hot staging adapter on Starship versions 2 and 3 reflects SpaceX's commitment to optimizing the design for improved performance and functionality. By enlarging the inner stage and increasing the distance between the hot stage rings, SpaceX can enhance the efficiency of the hot staging process, allowing for more effective separation of stages and release of gases during ascent. Overall, SpaceX's efforts to optimize various components demonstrate their commitment to innovation and efficiency in pursuit of their ambitious goals in space exploration. SpaceX is wasting no time getting into operations for Flight 6, which is set no earlier than November 11th. The next flight will be a chance for another pair, Booster 13 and Ship 31, to shine. On September 18th, or nearly 1 month before Flight 5, Ship 31 underwent its static fire test. Only 9 days after Flight 5, Booster 13 rolled out to the launch site and was placed on the orbital launch mount. SpaceX then completed a 33-engine static fire on October 24th, or 11 days after the latest flight. The booster appeared to complete the test without issue, promising Flight 6 is coming soon, as Elon Musk said. These moves also mark SpaceX's record turnaround for the pad. It only took 9 days to prepare it for a possible static fire after Flight 5, because the last flight didn't cause any major damage to the system. At present, B-13 is at the production site and is ready for flight readiness modifications ahead of IFT-6, including one last check and install the hot staging ring. Then roll the booster along with the ship back to the launch site for final testing and Flight 6. Talking about the hot staging ring, SpaceX recently salvaged the hot staging ring of Flight 5 in the Gulf of Mexico. It can be said that this is the first time that the company has recovered every part of a booster intact, setting a new precedent for SpaceX's engineering reliability. Due to the intense heat from the ship's engines, The ring is slightly warped, but its overall integrity is a promising sign for future missions. SpaceX's salvage of the hot staging ring has raised many questions about whether it intends to reuse it for Flight 6. Why not? The hot staging ring works based on simple physics, much like screwing a bottle cap. So if it remains intact with only surface scorching, reusing it would be perfectly normal. On the other hand, some may think SpaceX brought it back just for display. So how about you? Reuse or display? Don't hesitate to comment your thoughts below. As for Starship 31, its engines also need testing for landing capabilities. Moreover, the heat shield and flap system should be inspected. It seems Starship 31 still has older tiles, and SpaceX might replace them with new armor, similar to Starship 30, to ensure a successful landing in the next flight. One more piece of evidence for the feasibility of the November launch date of Flight 6 is the FAA's approval and regulations. SpaceX has secured FAA approval for both Flight 5 and Flight 6 simultaneously. The license, issued on the 12th of October 2024, covers the flight profiles for both missions, suggesting similarities between the two tests. This dual approval streamlines the regulatory process and potentially allows for a quicker turnaround between flights. This means Flight 6 could repeat what happened on Flight 5. In the upcoming launch, we'll witness another attempt to catch the Super Heavy booster with the Mechazilla arm, further validating SpaceX's ability to master this technology. However, upgrades are still necessary to prevent issues like the small fire that occurred during the previous landing attempt. Shortly after Flight 5, Elon Musk revealed a detailed update on Super Heavy. He first mentioned some of the outer engine nozzles are a little warped from high heating and strong aero forces, easily fixable. He later clarified, just inspected the Starship booster, which the arms have now placed back in its launch mount. Looks great. A few outer engine nozzles are warped from heating and some other minor issues, but these are easily addressed. This slight warping of the engine nozzles was expected, given the intense heat and aero forces endured during flight, but thankfully no explosions or critical failures occurred. Any other minor issues were likely related to sensitive systems in the upper part of the rocket, but thanks to the intact landing, evaluation and refurbishment will be more straightforward. It explains for Musk's confident assertion that the issues are easily fixable and addressed. After mastering the booster catch, SpaceX will challenge itself by catching Starship's upper stage in early 2025. Landing Starship in the ocean this year will allow SpaceX to improve the reliability and precision of this maneuver. Starship 30 achieved a controlled vertical landing during Flight 5, and this will be an opportunity to further refine that process. Flight 6 will be a crucial stepping stone for SpaceX's broader objectives over the next years and beyond. The first goal is to achieve a full Starship landing and then build the orbital refueling system. Refueling is critical as Starship consumes nearly all its fuel reaching orbit. For longer missions like the Moon or Mars, additional fuel will be needed to extend its range and ensure a safe return. If SpaceX successfully achieves full Starship reusability in early next year, they could conduct an attempt on the ship-to-ship propellant transfer to the same year, according to the user Alex. SpaceX demo of Starship's ship-to-ship propellant transfer next year will likely entail twin Starship launches and booster recoveries at Starbase. In-orbit refueling is indeed a complex technology, but once SpaceX can master it, it can confidently enter NASA's Artemis 3, which is expected to launch in September 2026. As the first crewed landing on the Moon since Apollo 17, Artemis 3 will request at least 15 Starships to execute. Starship cannot fly directly to the Moon but must refuel in Earth orbit before setting out for deep space. The Starship human landing system is just one vehicle requiring a single launch, but adding in all the launches needed for the fuel depot takes the total required into the high teens. The success of Artemis 3 will pave the way for more ambitious missions to the Moon and Mars. It's remarkable that a single flight to close out the year could pave the way for so many future milestones. Of course, that's the long-term story, but in the short term, if this mission launches before the year ends, it will set new records for SpaceX. The time between Flights 5 and 6 is shrinking. If Flight 6 happens in mid-November, the gap will be around 1 month, beating the previous record of just over 2.5 months between Flights 3 and 4. The launch of Flight 6 will contribute to making the last months of 2024 even hotter than ever. Blue Origin's New Glenn appears to be scheduled for a November launch this year. We'll carry the prototype Blue Ring payload tug and payload hoisting platform. in addition to serving as New Glenn's first national security space launch certification flight. This debut flight is more than just a technical milestone. It would wrap up the long-term delay of this most anticipated rocket. Development of the New Glenn rocket started before 2013 and was formally announced in 2016, with an inaugural flight planned for 2020. After multiple delays, as of October 2024, the first launch is expected to take place no earlier than November 2024. New Glenn is similar to its main competitor, Falcon 9. Like Falcon 9, New Glenn's first stage contains engines that can be relit during descent to allow a soft landing, and the rocket has 6 extendable landing legs that deploy just before touchdown. Meanwhile, Falcon 9 has 4 legs. While SpaceX currently lands its rockets on drone ships, Blue Origin also plans for New Glenn to land on a mobile, sea-based platform. The current New Glenn landing platform ship, Jacqueline, named for Bezos' mother, measures an impressive 115 meters by 45 meters in size, larger than the platforms used by SpaceX. Alongside SpaceX and Blue Origin, after some issues with the CERT-2 mission, ULA has maintained the goal to launch the first national security mission, USSF-106, on its Vulcan Centaur rocket at the end of the year. On October 21st, ULA shared photos of the 33.3-meter booster being hoisted into the vertical integration facility to begin the stacking process. By the 25th, its 11.7-meter Centaur 5 upper stage was added along with the solid rocket booster, being followed by payload fairings. The beginning of the rocket's integration comes as the U.S. Space Force continues to review data from the CERT-2 mission, which launched on October 4th from Space Launch Complex 41 at Cape Canaveral Space Force Station. And that just about wraps it up for today's episode. Thank you, and we look forward to seeing you next time.